could not use a Zoom. So we try to combine two kind of meeting software. So I hope it will be fine. But and I hope we can still follow his presentation, and we will have a good discussion today. So I would like to introduce Dr. Nielsen, but I think he would like to introduce himself to all of you. So without further ado, Dr. Nielsen, please, you could start your presentation.
Okay. My name is Nielsen. Here.
If possible,
And
yes,
I'm from
if
China.
possible, you could share your video if the internet connection is stable.
Okay, I will try.
Okay, you can start.
Okay. Maybe, I don't know
Oh, okay,
how.
no problem, no
Where,
problem.
where, where. Maybe. Okay, maybe I just talk
Okay, okay.
with you. Okay. Uh, yeah, my name is Nielsen. I'm from the China Cultural University, which is in China, and from the College of Engineering. Today, as asked from Dima-san, I will give a speech about control system for tomorrow's tractor. So this is my university, China Agricultural University. It is in Beijing here. This is China, the whole China, include this one. And this is Beijing here. My university is here. The Beijing is the capital of the China. The Beijing has a very hot summer and a very cold winter, and it is very dry for all the year. So I don't know anyone has been in China or not, but I think Beijing has very good, very good, how to say, the historical place that is like some uh, Great Wall or something. Later I will introduce it. And my university is from 1905 to 2022. That is around 117 years. Yes, and this picture shows the main gate of our university. And this is what I said, the historical place. Great Wall, Sun Place Museum, Temple of Heaven, and Tiananmen. The Tiananmen is maybe the most famous place in Beijing. And I don't know you have been there or not. And as you see, this is the map of Beijing here. And my university here is called Haidian District. And this is the central part of Beijing. And here is around, is next to the central part, maybe northwest, a little bit. And this is our university, China Cultural University. The first picture shows this is a gym on the playground. The second one is a library. The library is just built for maybe 3 or 4 years. It's a new library. And this is an old gate for our university, very old, maybe 50 or 60 years ago. And this is my college, the College of Engineering. And the final one, this is the apartment for the students. Here, I displayed a ranking that about agriculture and forests, and we can see that our university has a good reputation in this field. And in our university, it has 76 majors and around 13,000 undergraduate students and around 11,000 graduate students. So it's quite big university. And this is food in canteen. Since I have a good memory of good period with Dimas in Japan, so I know that maybe some of you has some religions, so you eat different food. But in our university, it can provide all kinds of food, even halal food or non-halal food. Any food is okay in our university. And this is the lab that I'm in. It's called non-destructive testing lab for agricultural and livestock products. Commonly, we have four kinds of samples to do the research. One is a crops, another is fruit, and meat and vegetables, like I showed this in this picture. And commonly, we use spectroscopy technicals to detect the quality of this kind of crops, meats, fruits, or vegetables. This picture showed a, a spectroscopy that we designed it. It is a kind of portable device to detect the meat quality. Uh, Actually, the meat quality evaluation is the most uh, popular research in our lab. Commonly, we detect the nutritional quality, like fat, the proteins, and water content. Besides that, we need to uh, grade the meat into different level. So we developed some other quality to detect, like the TBN, the bacteria, and sensory quality like tenderness, color, and the pH. And besides the meat, we also develop some device or method to detect the nutritional quality of seeds or crops, like protein and water content, or some quality of seeds like seeds vigors. So for vegetables and fruits, we commonly call external quality and internal quality. For the fruits, the external quality common like uh, color, danger, shape, sometimes weight, and the what is that? What is it? The width, height, and sorry, forgot that. Sorry. Other thing is the internal quality, like SSC, fondness, acidity, and the pesticide residue. And for the vegetables, the external quality is color, danger, and shape. And the internal quality is about the residue residue. And we developed such kind of device or system to do something like this, like food branding. We want to replace the people like this, use computers or some machines to finish the work that this one showed. And the other thing is a portable device to detect the food or some vegetables or meat quality outside, like this one showed. This is a handheld device to detect the grapes. This is not from our lab, but similar research field. And other thing is for meat. So we want to develop some meat grinding system that help Chinese the meat produce company to grade their meats into different level, because the different level will get different price. So today I will talk some research about the autopilot navigation system in tractor. So from this figure, we can see that recently the research hotspots in this field is about robotics, path tracing, self-adaptive control, GPS, steering control, and navigation control. And the left figure shows that in China, the most of the research focused on the robotics, path tracing, the steering control, navigation system, and the trailer system, uh, combustion efficiency, and model predictive control. All of these systems will be studied in China, and all of them are important parts for this autopilot navigation system. And today, I will introduce this one by one. And from this figure, we can see that almost 1/3 research is about path tracing. So the path tracing is very important in autopilot navigation system. And the second one is steering control. The steering control can control the tractors to travel according to the path that you set. So the steering control is very important, and it is a basic thing for this autopilot system. And after this, it is navigation. The navigation is important because the navigation can help the tractor to do the autopilot things like the unmanned vehicles or unmanned driving something. The path planning also important, just following the navigation system. The path planning is a kind of research about how to calculate a path that is easier for your tractor or your robot to pass through this field. And the last one is obstacles avoidance. This is commonly related to the safety. Like if there's a man just in front of your tractor, your tractor need to recognize it and avoid any damage to the people. So this constitute of the automatic driving system, the tractor. So first, I will introduce the path tracing. So what is the path tracing? The path tracing is the foundation of the unmanned tractor. The path tracing ensures that the vehicle follows a given route, like the left figure showed. We have a target path. That means we want our tractor to travel like this. But when we control a tractor, we cannot just let it travel like this because there's a lot of error or some other problem. So the real path will be like this. Actually, for path tracing, we need to make sure that this arrow is called lateral arrow smaller. So smaller trace the left arrow will get a good trace hitting performance. So the path tracing will can be used to evaluate the performance of your unmanned vehicles or autopilot navigation system. Of this is steering control system. Like I said, that the steering control system is very important because it is the thing that can control your vehicle's directions, and also it can help you to prevent the rolling of the tractors or vehicles. So this picture showed a steering system. This is the wheels. These wheels, if we roll wheels like this, it will be like this, and this one also this, and this is the gears. So the gears will be like this. Then this repeat my arm. The arm will be go like this, the circling motion, and then they will make the heavy wheel tight load like this, and this one will make this kind of left side steering track do like this circling motion. And if our wheels is here, it can control the wheels to change the direction, and then the direction of the tractor will be changed. So if we control the steering system, the direction of the vehicle will be changed. This is the most important thing for this autopilot system. And for navigation, the navigation is very key point of the unmanned tractor. This one said this tractor has a lot of sensors, and almost all of sensors for the navigation. Like this one, this is GPS. This is the camera, and this is the steering control system. This one is to measure the direction of the wheels. These wheels. So the 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 uh the result of this measuring will be given back to this steering control system, and this control system will check that these wheels get the set point or set direction or not. So the navigation system was used to get the position of tractor and achieve the precision heading control. And after this is the path planning. The path planning, it is an essential part of unmanned tractor. The path planning like this. According to the size of your vehicles or the room in the field, sometimes you need to use different path to go through some place. So first one is like this. The second one is like this. So this is for different kind of vehicles. If your vehicles is too big, sometimes maybe this turn cannot satisfy the turning demands. So sometimes you need to give a big circle to avoid any unsafety circumstance. Other thing like this. This is to use. This is for the vehicles that has a big width. So the vehicles will start from here, and they will not go to next row. They'll go to this third row, and like this. So this gives vehicles more room to turn. And so the path planning was used for turning path planning and obstacle avoidance. So path planning is very important when you need to make a turn. So last one is the obstacle avoidance. The obstacle avoidance that make sure that your unmanned tractor will working under safe circumstance, because we can see that in field there are some obstacles. If you want to your tractors, unmanned tractors work well, you need to let your tractors avoid these obstacles. This the same. Obstacles is recognize obstacles on the path. And then they will avoid the tractors of the vehicles. Commonly, our tractor has 4 wheels, but it can simplify into 2 wheels vehicle, like here they show. And according to this one, we can get this. This is the kinematics model. The X is here. This is X arrow. X arrow. Yes, this is Y arrow. So when the tractor traveling like this, it produces this X arrow and Y arrow. And this X arrow and Y arrow can be used to evaluate the lateral value of your tractor. That means the arrow between the planning path and your real path. And according to this model, you can try to change some parameters, some controlling parameters to reduce the lateral error to make your vehicles or tractors has a good performance during the traveling. So we can see that the X and Y is related to the V. V is the speed or velocity of the vehicles. Here, this is the V. This is the heading of the vehicles. And the theta is the heading of the vehicles. And we can see that the lateral arrow X and Y is related to one is speed and second one is headings. So actually, if you want to reduce the lateral error of a tractor, 2 things is important. One is speed, one is headings. So the speed we can control by some other method, like your let's say the what is that? Your motor or something. You can change it. You can change the speed of the tractors. So it can also help you to change the lateral errors. But other thing is the headings. This one is also important because actually we commonly when we meet some obstacles or we want to change the path of the vehicles, we commonly change these headings. Headings can help you to fix the uh, the posture of your vehicles. So that makes the vehicles go back to the set path. So this headings is a very important thing, but we cannot control this directly. Commonly, we just can change the direction of the front wheels, like this one. Here, this is the front wheels, and between the front wheels and the directions, there is an angle. We call alpha. This alpha can be used to change the headings. So the alpha is the parameter that you can control to change the headings, and then it can help you to change the posture of the vehicles. So here, the third one is about how to control the headings by control the alpha, the angle of the front wheels. Like here, this one. So how to get this equation? It's like this. If you have a speed like this way, and you can find that you can get 2 speed like y. So yx actually can be like this one, go to this one. So this one will be vertical to this direction, and this one, this one divided L, let's get this speed of this angle change. And if we use integration for this one, we can get the direction angle by control this one. So we can, so this called the angle of front with wheels is the important thing to change the headings. So later, most of the method to control the vehicles, they use some method to control this one, this angle of front wheels. So later I will introduce it. So firstly, it is a GPS navigation system. So for GPS navigation system, it is mainly to be used to get the position of your vehicles. And if you got position, you can try to fix the posture of your vehicles. So for GPS system, it commonly has two kind of GPS. One is like this one, single point. So you can get the distance between this one because there is a clock here. So you can get the time of flight of this waves, and you can know that the speed is 300,000. Yes, 300,000 per second. Yes, and multiply the height, you can get this distance. If you have 4 satellites, we can know that this point, this position will be here. If we get this distance, we know that the position will be like this. It is on the circle. So this one also is on the circle. On the circle here. Commonly, actually, theoretically, maybe 3 is enough, but commonly there are some other factors or affect the accuracy. So now we use 4 satellites to decide one position here. And another one is the real-time GPS. This one is a little bit different. It has a called base station. This base station also can receive the signal from satellites, and we also know the coordinates of this kind of base station. So we can compare this one with this one to fix some error from this one. Just use this one. So this one will be more precise to decide the position of your vehicles or something like that. Yes, this is the second one. It's called RTK GPS. Here, the satellite will give signal like this, like this. This one called the mobile station. You mounted it on the vehicles. And this base station, you put it somewhere, and you already know the coordinates. And then both of them will receive the signal from the satellites. After this, they will do the correction to this one, reduce the lateral error, like I said, lateral error for your unmanned vehicles. And another one is laser scanner navigation. So for GPS navigation system, we can see that it just can get the position of the vehicles. You cannot find any obstacles, maybe here, or people, or some tree or something. You cannot avoid it because you cannot sense it or detect it. So if you just use this kind of GPS system, maybe it's not safe to let it travel in the field. So someone also use laser scanner. It's called laser navigation. It is use laser to scan some area like this. This is laser, laser, laser. And if the laser meet some obstacles, it will reflect. It will reflect back to the sensor, so we can get something like this. And if there's no obstacles, so we can get these obstacles and distance and angle. So we can decide where there is obstacles. And also we can get the walls. It was like a straight line like this. And the light will go back to the sensor. So this one can be used to detect the obstacles in front of your vehicles. But for this one, it needs some reference to decide your position. You cannot just use this one to decide your position. It'll be difficult. So this one often used to avoid the obstacles. For example, someone mounted the laser scanner into a harvester, and they use it to detect the weight this boundary, the harvest and no harvest boundary right here. So this is the data that from this laser scanner. After they scan the road, we can see that the weight part will be higher than the already harvested part. So they use this one to decide the path that you are harvester traveling. In this case, this width just like obstacles, so it can detect this kind of obstacles, but they just need to harvest it. So it is cannot be used just by use GPS. If you use GPS, you cannot recognize where you already harvested, where are not. So for this scanner, it has some advantages to be used in this kind of case. But for this one, sometimes you cannot know that where your vehicle is. So just can, according to this weight, this boundary, decide the path. You cannot to set a path to go to from one point to B point. That is a problem. But for GPS system, it can realize. This is a machine vision system. It's also the same case to harvest the weight. And since this scanner just use the distance, so they said sometimes the weight will fall down because of wind or something. So if we use the laser scanner, maybe the fall down weight just like this. So actually it is no harvested, but the laser scanner will consider it as harvested part. So it will get something wrong in your system. So they develop another machine vision navigation system to recognize the harvest part, state part, no harvest part. And what they need to do is recognize this kind of boundary between them. And we know that we cannot just use this kind of camera, this picture, because we need to transfer it, because different mounted angle and different mounted position will affect the control parameters in your system. So after you mounted the camera in your vehicle, we need some transfer to be a bird view of uh, this this target, and then we can do some image processing to recognize the harvest part like this one and non-harvest part like this one. So this is uh, this is the image of the mature weight field. So the target is to recognize this line, and they try to make to find the difference between this no harvest and harvested part. So they use RGB value, that is three channels of the this kind of image. From this, we can see that in gray level on RGB color space, it shows different. Here, some mistake. Here, this is lower, and this part it will be higher. So if we use some image processing algorithm, it can be recognized between this kind of harvested part and unharvested part and get the boundary and let the vehicle just go along the boundary. Like this. This is what they did. They firstly they got the image and got and tried to transform it into the bird view. And then we try to detect the H point, like I said here. We draw a line and try to get the RGB channel value of each line. This, and they they try to divide it this two, and they get some point like this. This is a boundary. We can see that it is not a straight line. It's like this. So actually, our vehicle cannot travel like this. It's just the edge of the edge point of the boundary. So we need to make a straight line for the vehicles to travel. So after we detect the edge point, we need to do the regression, the fitting. So we have a lot of methods to do the fitting. Maybe the easy one, maybe just like the PLS. So after we got this fitting line, it can be used as a travel path for the unmanned vehicles. This is for different circumstances of the field to detect the boundary between harvest and some other part or unharvest. First one is the sparsely planted wheat field. That means this one, this part maybe has more weights. This one maybe less weight. So between these two, they want to try to find a way to detect the boundary between these two, and to try to introduce that their algorithm has some kind of stable detection ability. This is under the very strong illumination. And this one, it has some vehicle tracks. So that means the method that they developed that can avoid the track the vehicle track influence on this boundary detection. And this one is actually it is a boundary of this field, this weight field. So it also shows very good performance to detect the boundary of the wheel. This maybe some other plants. So they didn't detect this one or recognize this one as they precisely get this one. And other thing is the little straw going beside. This is some grasses. And this is the weight. So here is a boundary. So they use this kind of machine vision system to detect the boundary of this weight plant and to conduct the vehicle to travel along this boundary. So this is a machine vision navigation system. And the next one is inertial navigation system. All of these four are inertial measurement unit. It looks different, but uh, the parameters that they measure almost same. In this kind of inertial navigation, inertial measurement unit, it contains two kind of sensor. One is accelerometer, one is gyroscopy. The accelerometer can detect the accelerate speed, and this gyroscope can detect the direction of the moving object. So after we got these two kind of handles, and we use integration, we can get the position of the vehicles, and this called elements, the inertial navigation system. It is like this. The inertial navigation system will detect the accelerated speed and direction of the moving object. That means if you have a car, you get to accelerate, you get to the direction, this direction, vertical, yes, the direction. And after you get the direction, if the path is like this, you get direction, you get this one. If you use integration of this one, and this will be the speed. And you do the integration again, you can get the distance. If you get the distance and you get the direction of these vehicles, you can get the position or posture of these vehicles. So this the inertial navigation system use this kind of principles get posture and location of your navigation system. But this kind of navigation system has some very bad disadvantages. That is, if you get some error when you do the integration, this error will be accumulated during your integration. So the error will become bigger and bigger. So commonly, this kind of system was used as a subsystem to do the 8 system that to help the vehicles to get the position and the location. Like combine this inertial navigation system with laser scanner or laser navigation system or GPS or some other system. Just use this one. Maybe you need to correct the position or some location during some time, after some time, because the error will be accumulated. So actually nowadays we use the fusion of the sensors to detect the posture of the vehicles to decide how to control these vehicles, like GPS compass, RTK GPS, like I introduced before. This is a laser scanner. This is a camera, the machine vision. So this is similar to the weight case. This is rice. So the harvest rice by using all of these kind of things to decide how to travel in this field. Like The GPS compass is for the direction. And this one for the location. This scanner, like I explained before, is for detect the boundary. And this one also to recognize something like maybe this one fall down or some other case, or there is some obstacles or something like this. So they combine all of these sensors, they can get this kind of unmanned vehicles and get a very good performance in this kind of case. And also someone use some like camera with GPS to control uh, the vehicle to traveling in the field. In this system, we use one camera here and GPS here, and this is controller, and this is a computer to calculate the parameters, the control parameters, and the computer will give the signal to the controller. Controller will control the steering, the wheels. Here control the steering system. Then the direction and the position of this vehicle will be changed. And the GPS here was used commonly for the position like this one. And camera here is for the obstacles. So this one can be used to avoid obstacles like a collision, and it can be used to do some autopilot, some traveling in the field. And this is the uh, the path planning in the field, in the rice field. Sometimes we need to find the path in this field, but actually the path is not like that easy. It is like this, and the path has different problem. Like sometimes maybe you find some grass here, your path will be like this, or sometimes like this, or like this. So cannot be recognized well. So someone developed some algorithm. They use the the RGB image. They use they called green uh, ultra green image. They use double green minus B minus uh, R. That is red channel, blue channel, and G channel. And after that, they got some image like this. And then some image processing, like they want to find the differences between background and this dot. Here, they show this is green level. So in green level, we can see that this is higher, the plant is higher, and background almost there. So after that, we can get this. And then we make it. So this path. So it can help to help the vehicle to avoid this kind of path or this kind of path. So this is the key point. They found this kind of way to enhance the plant on the ground and enhance the roads, avoid. So actually, for image processing, the most important part is how to make sure that your algorithm is stable to recognize the roads or your traveling paths. Okay. And another important part is path planning. It's like this. Like I said that this is boundary. This is harvest part. This is not harvest part. After you finish this row, which row is the next? Like that, if your vehicle is too big, this turn may be not enough for your vehicles. So you may do something like this. And then here, like to make your vehicles traveling in big turn. Big, so not just the next to this row. So actually, this turn planning has a lot of ways, not just like this. This is just this turn. It depends on the room that you have or space you have here, or and your size of your vehicles. Here, like this. If there are some obstacles here or here, and it is not good shape, you need to find some good path to avoid this problem. So later I will show some common way to design the path and several kind of common the plan path like this. This is common operation path. The first is that here, 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 here. The second one be like this. This four commonly used in the harvesting operation. This path can be used to avoid some kind of that the space is not enough for your vehicles to make a turn. And the last one is very common one, just one row. So actually, after you finish the navigation system design, the most important thing is how to design the path for your vehicles to travel. And this is turn. So when your vehicles go to the end of this row, get to the end of this row, how you make a turn for your vehicles. This is just several. This is just three common one. You can find another one or some very useful one, and we can see that the R is the turning diameters, and this one will be bigger than this one, and this one is some other limitation here, here. So this one maybe for the vehicles, the bigger vehicles. This one maybe for smaller, something like this. Okay, I think that's all for today's speech. Thank you very much.
Okay, thank you very much, Dr. Nielsen, for the presentation. Is there any question from anyone? I'm sorry, this time this is not a common way to to share the screen, because we use two different platforms, because in China maybe some software is limited, so we cannot use Zoom directly from China. And there's a question here from Pak Eko. I will copy. Wait. Copy the question to Dr. Nielsen. And this is from Pak Eko, the condition. Could you see the question?
Yeah, let's see.
Hello?
Yes, yes, yes. Yes, I see it. Yes. Yes.
I'm sorry.
Actually, yes.
Okay, okay.
Uh,
Please continue.
the steering angle of the front, yes, the front wheel, it is used to control the direction. Yes. So when you make a turning, you just need to control the steering angle of your front wheels to make sure that your vehicle's headings or your direction of the vehicles can be can travel under the stated turn, like a half circle or some other pear shape or something. It is almost similar with the straight line. Yes, straight turning will not affect any steering angle. The steering angle of the front wheel is not just for turning; it is for the direction. So if you have a the stated direction of your vehicle, you just need to control the steering angle like I put here. Uh, here, you just need to control front, this steering angle of the front wheel to make sure that your direction has a correct direction. So that can make sure that your turning will be perfect. And the sad sleep, yes, the sad sleep now maybe not really taken into consideration. Yes, it is the how to say the future research about it, how to decide, how to detect the sad sleep, and this one also can improve the precision of the control model or control system, like reduce the future error or your direction error. I don't know.
Okay.
I explained it clear or not.
Okay. I hope it is enough for Pak Eko. There are more questions from Pak Darmanto here. I will copy paste it to you. Here. There are two questions from Pak Darmanto.
Okay.
Okay.
Actually, uh, there's no best path. You need to decide which path that uh, you want, just according to the vehicles and the situation or condition of the field. Sometimes you think maybe the semicircle turn is good, but maybe your vehicle is too big, so this semicircle turn cannot be finished. So you need to use other way. So sometimes you have to find a way to make a turn for your vehicles like that. And this fishtail turn here, here, if our vehicle is too big and the space in the end of the row is not enough, like this is the space, maybe this is the road, and if our vehicle is too big, we can see that this bar is bigger than bigger than this one and this one. So that means if you meet a turn, the vehicles and bigger. For this one, if your vehicles is too big, like this, you cannot make this semicircle, right? It's because it's too big. And for this one, it is big. So you can go like this, and here. This is for bigger vehicles. Okay. Uh, Actually, this autonomous structure already used in China, but in some big farm. Yes, because the farmland is very wide and very big. They cannot just use people. And the people, now China has not so much labors. So for seeding or harvesting, we use this autonomous tractor to do that. And uh, actually, there's no so much industry in China supporting this one. Most of this industry just launched some concept tractor. Like I showed here, it's called this one. This one here. This is from Case. This is concept autonomous tractor. Uh, yes, most of the tractors will be like a conception one, but some of the big farm already use it, and most of this tractor was used GPS as a navigation system. The most famous one is maybe Trimble. Uh, the Trimble designed a GPS navigation system for the tractor, and mm, the error is very small. The performance is good, but many of these kind of tractor just can travel under a set path. That means you need to plan a path, and the tractor will travel along this kind of path and finish the work. Something like that in China. Video. Okay, that's right. Maybe now is fine. Because I'm afraid that the network is not connection is not good, so cannot check. Okay, share my desktop. Okay. Yes, yes. You cannot see? Yes. Yes. Oh, that is uh, 8 years ago. 6 years ago, I think. After degree. This is about non-destructive, yes, measurement for the agricultural products. Maybe now use AR. Yes. I cannot find any, yes, spectroscopy for fluorescence. So just yes, 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 okay. Software, it depends. For um, the model parameters setting, we use MATLAB because Simulink is very convenient. Yeah, the Simulink. Yeah, but for control system, we use it depends on the chip. So we use C or Python. Yes.
Pak Dimas, are you there? Pak Dimas, Pak Iqbal, are you there?
Dimas, probably you are mute from our Zoom.
Oh, so you also cannot hear my voice before?
We cannot hear your voice, but Dr. Nisan, we can hear.
Oh, I'm sorry. I just unmute my Zoom here. Okay. Now you can hear my voice, right?
Yep.
I'm sorry. I'm sorry. Okay. We would like to thanks a lot for Dr. Nielsen for sharing his previous research to us. And I hope we really hope that this is the start for our future collaboration. We would like to prepare maybe better platform for discussing with you in the future, and we hope we will continue to collaborate. Thank you very much, Dr. Nissen. I think that will be the end of this first guest lecture on 3-in-1 program for 2022, and we will see you again in other session of the 3-in-1 program. Thank you very much, everyone, and see you again on the next session.